Hello, I am JD, and you're listening to the very first episode of The Ongoing. This episode is about an experiment that produced an unexpected result, one that shattered the old views of matter. And it reminds us that when reality contradicts our assumptions, it's an opportunity to rethink everything. In this episode, we are talking about Rutherford's gold foil experiment. I first heard about this experiment in high school. Even then, I found it genuinely interesting. Not because I fully understood all the technical details, but because the result struck me as a contradiction. On the surface, it sounds simple. You fire particles at a thin sheet of gold foil. Most go straight, but a few bounce back. That's it. And recently, for some reason, I found myself thinking about it again. Not as a science story, but as a doorway into something else. How do we deal with the unexpected? Let's go back. The year was 1909. In a laboratory at the University of Manchester, a small group of researchers set out to probe the atomic structure of matter by firing alpha particles at gold sheet. They were led by Ernest Rutherford, one of the most influential experimental physicists of his time. At the time, there wasn't much understanding of how electrons, protons, and other particles might be arranged inside the atom. Researchers had developed models to visualize the structure of the atom. But Rutherford wasn't satisfied with models that only looked neat on paper. Rutherford believed that no matter how elegant a model seemed, it meant nothing without experimental proof. To him, the only way to know whether a model of the atom was accurate was to test it directly and rigorously in the lab. And that is why Rutherford and his team were firing alpha particles at gold foil. And you may ask, why gold? Because gold is extremely malleable. You can stretch it into sheets just a few atoms thick. And if you held it up to the light, it will look like a fragile golden curtain, shimmering and delicate. Perfect for seeing how particles move through a physical structure. And why alpha particles? Because they are small, dense, and positively charged. Tiny cannonballs made of 2 protons and 2 neutrons. Dense enough to strike something, charged enough to be deflected. Ideal for probing atomic structure. At the time, the dominant atomic model was the plum pudding model. This model pictured atoms as soft, positively charged blobs like a pudding with tiny negative electrons scattered throughout like raisins. If that were true, the alpha particles should have passed through the gold foil with barely any resistance. That was the expectation. But that's not what happened. Most of the particles passed straight through, as predicted. Some were slightly deflected, and a few bounced straight back. That was the surprise. And it wasn't just unexpected, it was deeply unsettling. Because if atoms were soft and spread out as everyone believed, nothing inside should have been solid enough to cause that kind of a deflection. Some particles came back as if they had struck something dense and charged. Something no one had seen before. It was likely days or weeks of careful analysis, quiet, intense attention as Rutherford and team tried to make sense of what they saw. They looked at how many particles deflected, by how much, and at what angles. Slowly, a new model began to take shape. What if the atom wasn't soft at all? What if almost all of its mass and positive charge was concentrated in a tiny dense core at the center? And what if the rest of the atom was mostly empty space? That would explain everything. The alpha particles that passed through, they glided through empty space. The one that deflected, they came near the core and were nudged away. And the ones that bounced back, they hit the nucleus head on and were sent flying back. That tiny dense center was the nucleus. This was the moment the old views of atom cracked open. From this work emerged a new model. No more pudding. Now atoms were seen as mostly empty space with a small but powerful core, the nucleus, made of protons and neutrons, surrounded by electrons in motion. The atom, it turned out, was far more structured and far more surprising than anyone had imagined. And lately, I have been thinking about that. We carry assumptions about how things work, how our actions, plans, and beliefs will play out, how the world should respond. We fire energy into work, relationships, beliefs, and expect it all to flow the way we imagine. But sometimes something bounces back. A result we didn't expect. A movement that doesn't fit. And we are tempted to move past it, to ignore it, to hold tighter to the old model. But maybe, like Rutherford, we are being invited to reconsider the structure entirely. The gold foil experiment didn't just reshape science. It showed us that clarity often begins with contradiction. That what looks solid might be mostly empty space. and that sometimes truth is buried right at the center, not where we are looking, but where something pushed back. So here's something to think about. When life doesn't go the way you expected, do you adjust your assumptions and update your mental model? Or do you hold on tighter to the old model? Thanks for listening. I am JD, and this is The Ongoing.